Right then, November 2012, paper 2, calculator paper. I'll have a go and see how we do. Just find my calculator. Smash it. So, work out the value of x. Okay, first job then is to know, so this angle here makes it a straight line. So that is going to be 75 degrees because the pair of them add together to make 180. And now we need to set ourselves up an equation which says that 100 plus 50 plus 75 plus x is equal to 360, because the angles in a quadrilateral are up to 360. So 150, 225, x is 360. And so if I take 225 away from 360, I get my answer of 135 degrees. Three marks for that, one for 75 I'd have thought, one for setting up an equation, and one for getting to the right answer. Number 2, here are John's marks in a test. Which test gives the higher percentage mark? Okay, so we'll do test A first, and basically we do 18 divided by 25, which is equal to 0.72. And then if we times that by 100, we get 72%. So test A, you got 72%. Well done him, good man. Test B then. He got 30 out of 40, which is 0.75, and 0.75 times 100 equals 75%. So which test did you do better in? Test B. Alright. Super. Number 3, solving equations, everybody's favourite thing. So, in different ways, you could take off 8 and then divide by 3, but whenever I've got a bracket, I expand the bracket first. So that's going to give me 6x plus 12 plus 8 equals 50. Now I can simplify it by putting my numbers together, so 6x plus 20 equals 50. And now by taking 20 off each side, I get 6x equals 30, and x equals 5. So my answer is going to be x is equal to 5. Now before I crack on with the next question, I will just substitute that in just to check that it makes sense. 2 times 5 is 10, 10 plus 4 is 14, 14 times 3 is 42, plus 8 gives me 50. Double check, because 4 marks available there. Silly mistake, and you lost 4 marks. So double check. Put each of these numbers into the correct box. Okay, so what we've got 2, 8, 11, 27, 64. So it's just a case of knowing your numbers really on this one. Square numbers, well, my only square number is 64. And luckily for me that is a cube number as well. 8 times 8 for your square, and 4 times 4 times 4 is 64. Odd numbers, so I've got 27 and 11. 1 is a cube number, 1's a prime number. Okay, well 3 times 3 times 3 is 27, so there's your cube, and 11 is a prime number. Good news. Cube number, prime number, well 2 is the only even prime number, so that's going to go into there, and then 8 is 2 times 2 times 2, so that will go into there. Why is it never possible to put any number in the shaded box? Okay. So, I don't know how to explain this one really. A square number is a number multiplied by itself, and so has a factor. least one factor other than 1 and itself. A prime number is a number whose factors are only 1 and itself. And so we can't have both. So I think that will do. Number 5, work out the value of a when x equals 6 and y equals minus 1. Alarm bells on the minus 1. As soon as you've got a minus, just take care that you don't mess it up. I'll do it over here. So a equals, so 4 times x, that's 24. Then we are adding 3 times y. So adding 3 times minus 1 will give you negative 3. And in the bottom bit, denominator, you've got 6 take negative 1. Right, if you've done that, then it should just be a case of negative number work really. 24 plus a negative, 24 take 3, give me 21. And on the bottom, we've got 6 take a negative, means we're going to add to get 7. And finally, a equals 3. That's going to be our answer. Let's plug you into there. Again, take your time with these questions. 3 marks should be gettable, so take your time. Circle the two equations that are equivalent to 2y equals 3x plus 4. Well, 2 equations here and 2 marks, so we don't need any explanation. I'm going to go with a sort of getting rid of the ones that aren't approach. So, 2y equals 3x plus 4. Well, we can't just swap the y and the x over to the other side to get 2x equals 3y plus 4, so it can't be that one. That's no good to anyone. Now, if I'm going to make this y equals, then I've got to divide by 2, which means I've got to divide this by 2 and that by 2. So, y divided by 2y divided by 2 is y. 3x divided by 2 will be 3 over 2x, which is looking promising for here, but then 4 divided by 2 is 2, so this here should be a 2 at the end there. So that cannot be true. So I'm happy now at this point to say, well, that are my 2 answers, because it's told me there's 2 answers, and it can't be the other 2. However, we should be able to rearrange this to get to these, and this to get to that. I'll let you have a go at that. The diagram shows a circle inside a square. Work out the area of the circle. Okay, so there's your rule for area of a circle. Area equals pi r squared. So the key is just working out what the radius is. Well, it's 8 centimeters all the way along. Your radius is going to be 4. So your area is going to equal pi times 4 squared. 4 squared is 16, and then finally we're going to get our answer by typing that into a calculator. So let's go scientific and find the pi button. There it is. So 16 times by pi is equal to that there. I've forgotten what it was. 50.26548. 8, which we will give to 1 decimal place or 3 significant figures. So there's your answer, 50.3 to 1 decimal place. Work out the area of the triangle. Now you've just got to be careful on these, because we can use trigonometry to work out the area of a triangle if need be. However, the most basic rule is area of a triangle equals base times height divided by 2. And we've got the base and we've got the height. So that is the rule that we want to be using. 8.6 times by 5.2 divided by 2. That's going to be our answer. So the area is equal to 8.6 times 5.2 divided by 2 is 22.36 centimetres squared. Now it's worth saying at this point that this question has already got the units on. It says centimetre squared already. There's always 1 mark available for putting the units. So it doesn't have units, you need to make sure you put centimetre squared. Also, again, while I was just saying that, I was just checking the question in my head. Give your answer to one decimal place. Well, I'll do it to two decimal places, so I'm going to lose myself a mark there. So just always, before you go on to the next question, make sure you check your answer is what they're asking for. You don't want to lose a mark for something like that. Number 9. Show that the equation x cubed plus 8x equals 30 has a solution between x equals 2.2 and x equals 2.3. Okay, so it's like a trial and improvement question, so that would be the approach I'd have. There's my table, x, there's my rule, and then I'm going to say whether it's too high or too low. So 2.2 into it. If I put that into here, 2.2 cubed plus 8 times 2.2 is equal to and I make that to be 28.248. So in terms of my comment on that one, well, I'm aiming for the 30, and that is too low. So we try the next one up, 2.3. And see what that is equal to. 2.3 times 2.3 cubed, and then we're going to add on 8 lots of 2.3, and we're going to get 30.567 as an answer to that, and that is too high. Now for me that's enough for the 2 marks. You've done it once to see that's too low and once to see if it's too high. We can then carry on further to get it to one decimal place, but it doesn't ask for that. It just asks for a solution, asks to show that it's got a solution between 2.2 and 2.3, where we have. 2.2 is too low, 2.3 is too high, so the solution must be in between them two. Number 10. A drink is made from 1.5 litres orange juice and 7.5 litres lemonade. What fraction of the drink is orange juice? So we've got 1.5 litres of orange juice divided by total amount, which is going to be 7.5 add 1.5, which will be 9 altogether. So now to write that in its simplest form. Well, we can't have 1.5 a decimal in the fraction, so I'm going to double that, which means I need to double this. And then simplifying that is going to be 1 over 6. So 1 over 6 is my answer, 1/6 of the total amount. A different drink is made from 2 litres of blackcurrant juice and 12 litres of water. How much more blackcurrant juice should be added so that 25% of the drink is blackcurrant juice? So this is the way I would do that, is I'd set up a little table and say, well, there's my blackcurrant, at the minute I've got 2 litres out of 14 altogether. What is that as a percentage? Well, 2 divided by 14, same as a seventh, and if I times that by 100 to get my percentage, then that is 14.28%. 29% I think it was. Okay, so if I make that 3 litres of blackcurrant, then that's going to give me 15 litres altogether, and then 3 divided by 15 and times 100 is going to give me 20% of my drink is blackcurrant. So if I make that 4 litres, that's going to give me 16 litres altogether, and then 4 divided by 16 times 100 is going to give me 25% altogether. So how much more blackcurrant juice should be added? Well, I've got 2 already, I need to get up to 4, so I need to get myself 2 more litres of blackcurrant juice. And there's the answer we're looking for. Number 11A. Work out the mean number of fish caught per hour in week 1. Okay, so to work out the average, I'm going to do the total time fishing, which is 2.5. Sorry, no, I'm not. I'm going to do the number of fish he caught divided by the number of hours that he was fishing. 4 divided by 2.5. Got the mean number of fish, and so that is equal to 1.6 fish per hour. That's his average, his mean number of fish caught per hour. So Mark says, one of the fish I caught weighed 5 kilograms. In which week did this happen? I can make sense of this table a little bit. So it's 4 fish caught and their average is 1.2, 1 fish caught, their average is 2.3, 6 fish at 0.8 average, and 3 at 1.9 average. So what I'm going to do is I'm going to add an extra table into there, extra row into there, of the total weight of all of his fish. So this week there are 4 fish at 1.2 is going to give me 4.8 kilograms. Hopefully that makes sense. The next week he caught 1 fish and the average is 2.3, so that fish must be 2.3 kilograms. The next week he caught 6 fish and 0.8 kilograms on average, so 6 times 0.8, which is going to give me 4.8 kilograms. And then finally 3 fish and the average of 1.9, 3 times 1.9 is 5.7 kilograms. So that was the total weight of all of his fish. So now, in which week did he catch one which weighed 5 kilograms? Well, his total weight wasn't above 5 kilograms until week 4, so it must have been in week 4. So, week 4, and I'll probably put a bit more explanation there because the star question give a reason. I think we've given enough reason up there, but just to make sure we get that star point. So, as this was the only week in which his total weight of fish was over 5 kilograms. So it must be this week. Something along those lines. I think we'll just make sure that you get that extra mark. So week 4 is your answer. Alright. Super. Number 12. Flying through it. Expand and simplify x plus 6 squared. Unfortunately we can't just say that's x squared plus 36 and just square both the things. X plus 6 squared is the same as saying x plus 6 multiplied by itself. So now we've got to expand this bracket. And so we use the FOIL method, or the box method if you like. X times by x is x squared. X times by 6 is 6x. Oop. I have to start that one again. Okay, so that's x squared plus 6x plus another 6x, and then the 6 times the 6, remember to multiply, is 36. So we get to there. And then finally, we can simplify our x's. 6x plus 6x is going to give me 12x altogether. So that's going to be our answer. Expand and simplify. This one here, and it's got a star by. I find that a bit surprising, and we'll work through it step by step and see if there's any explanation we can give as we go along. So 9w times by 3x, so we're going to times everything by the whatever's in front of the bracket. So 9w times 3x, that was 27wx. Take away 9w times 4y, well 9 times 4 is 36, so it'll be 36wy. Be careful with a minus sign here, so minus 5w times x will be minus 5wx, and then minus 5w times positive y will give you minus 5wy. So we've got that far, And now then we've got 27wx there. I'm going to take off 5wx there. So that gives us 22wx. And then we've got minus 36wy, and we're going to take off 5wy, which is going to give me minus 41wy. And that's your answer. You're done. I'll have a little look in the mark scheme in a minute and see whether that's enough for the 4 marks, but can't see what else we can do to that. Simplify. Possibly we could take a factor out of this. We've got a w in both. I don't think that's what they're after, but we've got w in both. So we could factorise that to 22x minus 41y. There's no number that goes into 21 and 41. 41's prime, so can't do any more than that. So maybe they won't want that as an extra step, as an extra mark. I think that's probably enough. I'll have to have a look in the mark scheme and see that one. Number 13. Matt made this spinner. He spins the arrow 200 times. How many times do we expect the arrow to stop on the number 5 if the spinner is fair? Well, 5 equal sections. So we'll do 200. Oh. And we shall divide that by 5, which is going to give us 40 times altogether. So our answer to that is 40. 13b. Do you think the spinner is fair? I doubt it, never is. Look at the table. No, you can see 65 and 27, not really close together. In fact, it's quite biased towards 65, towards the number 3. So, I do not think the spinner is fair, as there is a big difference between the number of times it landed or it stops on 3 and the rest of the numbers it stops on. I could go to the top a bit more, I suppose. If it was fair, you would expect the frequency to be about the same for each number. The pentagon has a vertical line of symmetry. I'm going to have to draw that one. There it is, roughly speaking. Treat myself some dots there for a dotted line of symmetry. There we go. The ratio of angles BCD is 6 to 3 to 4. Work out the size of angle B. Right, I'm going to label some stuff up. This whole angle here, so the whole of B, is 6x, because there's 6 parts there, using the ratio, 6, 3, 4, meaning that there's 3 parts and 4 parts for C and for D. Now, using the fact that it's symmetrical, means that the angles on the other side are going to be the same size. So that there is going to be 4x, and that there is going to be 3x. Right, my dotted line's getting on my nerves now. There we go, that looks a bit better. So, set ourselves up an equation. That's the hard part, is getting that bit labelled up. Once you've done that, you've now got 6x plus 3x plus 4x plus 4x is equal to, and it's a 5-sided shape. A 5-sided shape is 540 degrees. Now, it's 5 marks question, so I might be tempted to say why 540 degrees. Sum of interior angles equals number of sides minus 2 times 180. Haven't really squeezed on there very well, but hopefully that makes sense. So for us, we've got 5 sides minus 2, 5 minus 2 times 180, and 5 minus 2 is 3 times 180, which equals 540. So that tells you what the angles add up to. Now I've got this equation here which says there my angles, they add up to 540. Solving it now should hopefully be fairly easy. 6x, 9x, 12x, 16x, I've got 20x equals 540. And if 20x equals 540, then x is equal to 540 divided by 20, which is 27 degrees. So now I've got x. Finally, I've just got to make sure I answer the question. The size of angle B. So angle B equals 6x, which equals 6 times 27, which is, calculate our job, 162 degrees. Jobs again. So I'm thinking 1 mark for labelling up your angles correctly, another mark for working out the size of the interior angles, another one for setting up an equation, another one for solving the equation, and then final mark for actually working out the size of angle B using the solution he had. Nice, I like that one. Number 15, work out the height H. Right, so it's a right angle triangle, and working out the height, so it's a bit of trigonometry basically. SOHCAHTOA, hopefully you know the triangles. SOHCAHTOA. If you don't know them, there's some good acronyms on Google. You can get on Google, and there's some good sort of ways of remembering them if you're struggling to remember them, but you definitely need to know them. So now in terms of our question, well, there's our angle. The H is opposite, and the 16 is adjacent to it, next to it. So O and A, we're looking at this rule on the end here, TOA. Right, we're trying to find the opposite, so I cover the opposite up, then I do tan times by the adjacent to get my answer. So H is equal to tan 31 times by the adjacent times by 16. Now we're back to our calculator. Tan 31 times 16 is going to be, my calculator hasn't got it right, good news. I'll use a calculator on here instead then. Let's clear all of that. Okay, so tan 31, and then we times that by 16, and that's my answer, 9.613. 9.6137, 9.7699 I think it was. Does that look realistic? Yeah, 16, that's H, 45 would make that 16 as well, so it's less than that, so that's about right. I'm not going to leave that as that number though, let's round that to 3 significant figures. 9.61 to 3 significant figures will be our answer. Job's a good one. Number 16. The same students take 2 tests. The scores out of 50 are represented on the cumulative frequency graphs. How many students took each test? Well, that's going to be the number that there is there. So 80 students took each test. I like that question, that was a nice easy one. Work out the median score for each of the tests. Okay, so for each of the tests we basically draw a line across at halfway, so 80 took the test, so we're going to do a line across at 40, and that is our median for test A, and that is our median for test B. So we're looking at 20 for test A and 35 for test B. The interquartile range for test B is 13. Work out the interquartile range for test A. We're doing it for test A. Test B is 13. So interquartile range, you're looking at your quartiles. 40 was a halfway point. 60 is your upper quartile. So that's 25. And 20 is your lower quartile, which is 15. So your upper quartile minus your lower quartile is going to be 25. Take 15, which equals 10. So our answer is equal to 10. Which test is more difficult? Give one reason to support your answer. Okay, well the interquartile range is slightly smaller for A than it is for B, which means the scores were closer together. Doesn't really tell us how much harder the test was. Just means that the scores were closer together on that one. There was less higher and less lower, and they were all closer together in the middle. So that doesn't really tell us which one's harder. How hard a test is, I'll be looking at the median score and saying, well, test B is the average score, or the median score was 35, and for A it was 20. So I would say that test A is more difficult. Reason, because the median score for test A is 15 marks lower than it was for test B. Just check that I've read that right. I've got them the wrong way around. No, test A is 15 marks lower than it was for test B. Yep. Excellent news. Hopefully we're happy with that one. Number 17. These expressions represent three numbers. Work out the mean in terms of x. Give your answer in its simplest form. Right, so a mean average is when you add them up and divide by how many there are. So let's do exactly that. X plus 3 plus 4x. Add them all up. Is 4, 5, 6x plus 3. So the mean equals 6x plus 3 divided by 3, which equals, so now divide each part. 6x divided by 3 is 2x, and 3 divided by 3 is 1. So our answer is 2x plus 1. Okay, so just remember what mean means, and do exactly that. Simplest form then just comes naturally, 2x plus 1. Job done. Solve 18 plus 5x divided by 3 equals 10 minus x. I don't like fractions in algebra, and together it makes life quite hard, so first job is to get rid of it. On this side I'm going to get rid of the divide 3 times 3, and I'm going to do the same to the other side. So I'm going to be left with 18 plus 5x on that side, and if I times both of these by 3, minus 3x. If you rather, put an extra step in there saying that. And get there that way instead. Okay, and now we're just solving equations. Minus 3x is lower than 5 plus 5x, so I'm going to add 3x to both sides. 18 plus 8x equals 30. Then I'm going to take 18 off the left side and 18 off of that side. I get left with 8x equals 12. I'll try and keep my equal signs lined up. So now x is equal to 12 divided by 8. X is equal to 1.5. And there's my answer. Check it. 1.5 into this. Well, 5 times 1.5 is going to be 7.5. Add on to 18 is 25.5. And if I divide 25.5 by 3, I think it's 8.5, just check. So I get 8.5 on this side, and then 10 minus 1.5 is 8.5. So yes, my answer's correct. Before I go cracking on to the next one. Number 19, work out the equation of the line shown. It's a straight line, so straight away we want to be writing down y equals mx plus c. First job. M is your gradient, c is your y-intercept. So gradient first. Well, for every one to the right, we're going half a square up. I can go further along, go one to the right, and I'm going half a square up. One to the right, half a square up. So my gradient means how many squares up for every one square to the right, or one square to the right, half up, one square to the right, half up. So my gradient is equal to a half, or 0.5. So I've got 0.5x, and then plus, and c is my y-intercept, or where does it cut through the y-axis? 4. Y equals a half x plus 4. Job done. So 3 marks for that. I'm guessing you get 1 mark for knowing it's in the form mx plus c. Then m is your gradient, c is your intercept. 1 mark for each of them as well. Nice one. The diagram shows a circle centre 0. Work out the value of a. Now we should know that this angle in the centre here is double the angle there, so this angle here is going to be 2 lots of a. But we can't work this out yet. What we need to notice is that because this line here, OC, is the radius and OB is the radius, both of them are equal, which means that angle there is going to be equal to one on here, because we've got an isosceles triangle. Okay, so now I want to call that angle in the middle there angle x, and I'm going to say x equals 180 minus 42 minus 42. So x is equal to, take off 84 is 96. Check on your calculator if you want. Yep. And then a equals 96 divided by 2. 2. And I'm going to put there angle at centre is twice angle at circumference. And so A is equal to 48 degrees. That's annoying me. I'm going to have to change that. Here we go. Job's again. So A is equal to 48 degrees. Okay, and I guess you could put an extra reason here saying, a little arrow to this saying isosceles triangle OB equals OC. But I think for 3 marks we've put enough explanation there. We've written that that's 42, we've said 180 minus that is that, and then we've given the circle theorem rule to go with it. So I think that's enough marks for the 3 marks. 21. Whoa, that's a cool looking thing. Write down the value of x, give a reason for your answer. So they've stated they want a reason on this one, so we need to make sure we put that. We've got a tangent here. If we've got a tangent, then it's probably going to be alternate segment theorem involved somewhere. Write down the value of x. Here, x is there. So if I just look at this triangle here, the RQT, and ignore the S bit over there and look at RQT, then the angle made by the tangent is the same as the angle on the alternate side of your triangle made from it. In other words, x is 64 degrees, and your reason, alternate segment theorem. Okay, now for B, work out the value of y and give us a reason. What's that going to be? Well, y is there. We need to ignore this line that we've got down the middle there and just look at the quadrilateral. What do we know about cyclic quadrilaterals? They're not even, they're not equal to each other. They add up to 180 degrees. So y is 180 minus 83. So, a bit of working out. Minus 83, which is 97 degrees. Opposite angles in a cyclic quadrilateral add up to 180. It doesn't ask for that, but clearly that's what you've used, so I don't think it hurts to write it down there. Let the examiner know that you know what you're on about. (22) The table shows the probabilities that I'm on time or late for work each day. It also shows the amount of pay deducted for being late each day. That's a bit harsh. Work out the probability that was exactly £16 deducted over 2 days. Okay, so how could he get £16 deducted? Well, he could be late here, so that's £16 in one hit, or he could be late twice there. So what we're going to do is we're going to work out probability of late twice up to 30 minutes. To do that, we times the two together. The probability of it happening once is 0.3, and again is 0.3. So altogether is 0.09 is the probability that he'll be late twice up to 30 minutes. So he could be that one. He could be the probability of late once between 30 mins and 1 hour. And that's very easy to work out because it gives it to us. It's 0.1. So now, probably that I've exactly £16 deducted over 2 days. Okay. If I'm probably late once, then you're on time. On time once and late once between that time. So it's going to be 0.6 times 0.1. Which is going to be 0.06. Okay. So probability deducted exactly £16 is going to be them two added together. Which is going to be 0.15. So your answer is going to be 0.15. There we go. I'm getting there. So 23. The diagram shows a sector of a circle. Work out the area of the sector. Give your answer to a suitable degree of accuracy. Right, so there's my rule. Area of the sector equals pi r squared divided by 360 and times the angle. Essentially you work out the area of the whole circle, divide by 360 to work out 1 degree, and then times by 130 to get there. So, let's work it out. Area equals pi r squared. R is 8, so pi times 8 squared. Times the angle is 130. I've got to divide by 360. So 8 squared is 64. So I get myself to that point there. Pi times 64 divided by 360 times by that. So now it's calculator jobbery. Pi times 64 first, then divide by 360, and then times by 130. It should give you 72.6056963. And so, suitable degree of accuracy. Well, 1 decimal place, that's good to me. Or three significant figures, however you want to do it. I'm not sure on the answer bit on this one whether it gives you the centimetre squared or not, but that is centimetre squared, so include that in your answer. 24. In the diagram, angle A is obtuse. Cool. Work out the size of angle A. So this is trigonometry, and you can either do sine rule or cosine rule. Now I always start with sine rule and see if it will work for me. See if that's going to give me an answer. So there it is, there's my sine rule. You should be able to find that on the front of your books. B we know is 35, so I can swap that for 35. There. Can't see it very well. Length B is 8, so I can swap that for an 8. Length C is 10, so I can swap that there for a 10. That's all the information I know. So if I want to know C, then that's fine, because I know 3 other bits of information here. But I don't want to know C. I want to know what A is. So I think what I can do then is I'll use sine rule to come up with C, and then I can then do 180 minus it to work out what A is going to be equal to. Yep. Now the alternative is we could use this rule here, the cosine rule. Cos A equals, well, B we know, C we know, A we don't know, and then 2bc, so we can't use cosine rule either, so that's no good to us. So we're going to use this here. So if we ignore this bit here, get rid of that now, and just focus in on the bits that we've got some information to work with. There you go, so it was never there. Then we get left with eight over sine 35 is equal to sine C. So we can rearrange that by turning it the other way up. Sine 35 over 8 is equal to sine C over 10, and then rearranging again we can get 10 lots of sine 35 divided by 8 equals sine C. So we're starting to get somewhere now. So sine C is going to equal, on a calculator, 10 times sine 35. Can't do it on my calculator, so I'll have to do it on this one. Sine 35 times 10, divide that by 8, gives me what sine C is equal to. So 0.716970545438807. See how much I can remember that. 0.716970545438807. There we go. Look at that. So finally, C equals the sine inverse of that. I should know how to do that on a calculators. I don't know how to use it on this calculator, but I'm sure I can work it out. There we go, sine inverse of that. We've got 45.8. There's our answer for C. Winner. So that there is 45.8. So finally, A equals 180 minus 35 minus 45.8, which equals 99.2, which is good news because that's obtuse, and the question told me that that was the obtuse angle. So there we have it. I don't like trig, got to be honest, but hopefully you followed that and it makes sense. If it don't, you know where to come and find me, and I'll have another go explaining it. 25. N is a positive integer. Prove that n squared plus 3n plus 2 must be a multiple of 2. Right. Now there's probably different ways of doing this, but I am going to try and factorise it first in the double brackets. So if I make that n plus 2, n plus 1, then I've got n squared plus 2n plus 1n, which is 3n plus 2. So I've got that there. So better write this properly. N squared plus 3n plus 2 is equal to that there by factorising into double brackets. Now then, if it's a multiple of 2, then it means it's an even number. Well, n plus 1, if n is odd, so if n is odd, then n plus 1 is even. If n is even, then n plus 2 is even. So either one of these two brackets must be even. Hopefully that makes sense, yeah? So I've factorised to this. If this is even, then this whole bracket here must be an even number. And if this is odd, then that whole bracket there must be an even number. And if I multiply any number by an even number, then my answer must be an even number also. So it's relevant what the even number is. If you times anything by an even number, your answer is going to be even as well. So this must be a multiple of 2 because it's even. Maybe I'll put that because it is even. They're tricky them questions, and I hope that kind of follows and makes sense. Again, if you're not sure, ask me or your teacher, and hopefully they'll be able to explain it to you better than I've managed. 26. On the axis, make a sketch of y equals x cubed. We kind of need to know what y equals x cubed looks like, and it's going to be quite hard to draw without having a board. But essentially, we start like so, and then we even out and go through the origin, and then back up the other side. So it looks something a bit like that. If it was minus x cubed, it would go the other way. It's like the reflection of that. Okay. The sketch of y equals 1 over x. Again, this is another one we just need to know. And y equals 1 over x doesn't touch the axis. So it's like a curve here. Like so. The key bit is it doesn't touch the axis because you can't divide by 0. I'm wondering if it'll let me do it like this to save me trying to draw that again. There we go. So y equals 1 over x looks a bit like that. If it was minus 1 over x, then it would be these two corners instead. So it would be this quadrant there, and that quadrant there, second and fourth. Alright? There's some graphs you just need to know, and that's one of them. Is this a right-angled triangle? You must justify your answer. Shame you can't just put yeah, leave it at that, innit? It's got a star as well, so imagine you explain it to someone who doesn't really have a clue what they're on about, and hopefully you better do it. Okay, so if this is right angled, then what must be true? Then Pythagoras' theorem must be true. Okay, it's the first statement to put. Okay, because there's any right angled triangle, then Pythagoras' theorem holds true. As does SOHCAHTOA as well, but we've got 3 sides. Okay, so now which one of these is going to be the longest side? Well, this here looks like it's going to be the right angle, so I'm going to go with that. Might work out to be wrong, but I'm going to go with that. I'm just going to plug the whole thing into Pythagoras. So a squared plus b squared equals c squared. So we've got that, it's Pythagoras' theorem. And we put our numbers in, then we've got 5.8 times 10 squared. So there's my A. There's my B. 1.16 times 10 cubed. And that must equal to 580 root 5. Squared. So, I'm going to whack this into my calculator and see what I get, I think. 5.8. 5.8 times 10 squared is 580. So that first bit is 336,400 squared, and then 1160 is equal to 13,456,600. And then finally 580 root 5 squared. Which is equal to 168,200. So finally, if I add them two together, 336,400 plus 1345600, I get 168,200 is equal to 168,200. Pythagoras' theorem is true and the triangle is right angled. Right, so I've sort of done that fairly quickly. It would have been easier if I had paper, to be honest, but basically I've said that there's Pythagoras' theorem and I've put my numbers in, so I've said that that's the short side and that's the short side here and that's my long side, and I've put it in my calculator. So 5.8 times 10 squared, and then squared, is equal to 336,400. And then I've said that 1.16 times 10 cubed and squared is equal to this here. And then I'll type this third into my calculator, 580 root 5, and squared it. And I get 168,200. and then by adding them two together I'm saying that this left hand side is equal to the right hand side, which is obviously true, so Pythagoras theorem is true, and so we must have ourselves a right angle triangle. Hope that makes sense. 28. Solve the simultaneous equations. Two solutions. Winner. So simultaneous equations, if they're both linear, so there's no squared involved, then we do the thing where we make the x's and the y's are the same. If we've got squared involved, then your best bet is to substitute your linear one into your quadratic one. So for us, that's going to mean my y equals 2x squared plus 4, like so. I'm going to take my y out, I'm going to swap it for what my first equation is, 10 minus x. So I get to that there. Now I've got to rearrange this. I'm going to rearrange it to equal 0, because if I want to solve a quadratic, which is what I've got, then I'll make that equal to 0. So I'm going to add x to both sides first of all. That will get rid of this x and give me a x on the other side. And then finally I'm going to get rid of that 10 to make that 0, which means I've got to take 10 off this, and 4 take 10 is negative 6. So I've got to that there. And finally I'm going to make it equal 0, because to me that looks a bit nicer. So how do I solve quadratics? Well, I've got my quadratic formula that I can use, or I can do double brackets. So that's the way that I'm going to go with this and see how that goes. And you don't always know until you do it. I need to factorise this here, so I'm looking for numbers that multiply to give me minus 6. So I could have minus 1 plus 6. I could have plus 1 minus 6. I could have minus 2 plus 3. I could have minus 3 plus 2. So that's going to give me that. So now, just because I've done these a bit, I'm looking for 1x there. What if I can get 2 lots of my 2x and then take 3x off? That's going to give that to me. So I'm going to go minus 3 plus 2. And I can check it. 2x squared, 2x times x is 2x squared, minus 3x, and then I've got plus 4x there, which gives me minus 3 plus 4 is plus 1x, and then I've got minus 6 there. Okay, so that's my factorised form of that there. Okay, now it's tricky, I can do that quite quickly, because I've been doing maths for quite a while. But it's quite hard to do, and you might have to do quite a few brackets until you get a winner, until you find one that works. Okay, so now I know that 2x minus 3 equals 0, or x plus 2 equals 0. Alright, so either the first bracket equals 0, or the second one does 0 times anything, and give me 0, or anything times 0 is going to give me 0. So to solve this one, well, this is going to have to equal 3, which means x is going to equal 1.5, or x equals minus 2, because minus 2 plus 2 is nothing. Cool, look at that, looks good, doesn't it? So I've worked out that x is 1.5, or x is minus 2. Job done, finished there? Unfortunately not. So we need a y value. Which one are we going to use? Well, 10 minus a number is a lot easier than squaring it and things like that. So 10 minus x. So for this one, 10 minus 1.5 equals 8.5. So that's my answer to that one. And then this one, 10 minus negative 2 is 12. So I've got myself y is equal to 12. Now I know that works for both of them. I can try that into here. I'll just get my calculator out, but for the second one, minus 2 squared is 4, times 2 is 8, plus 4 is 12, which is what we got y to be. 1.5 times 2 is 3 times 1, I think it's 4.5 plus 4 is 8.5 and 8.5. Yep, so that works. Winner. Gotta love maths. And then you're done. Excellent. Alright, have a look through all of them and ask if you've got any questions, okay? Either myself or your teachers will be happy to help.